Example 3.8. When a situation demands our immediate action, it takes some time before we really respond. Reaction time is a time a person takes to observe, think and act. For example, if a person is driving and suddenly a boy appears on the road, the time elapsed before he slams the brakes of the car is the reaction time. Reaction time depends on the complexity of the situation and on an individual. You can measure your reaction time by a simple experiment. Take a ruler and ask your friend to drop it vertically through the gap between your thumb and forefinger. After you catch it, find the distance d traveled by the ruler. In a particular case, d was found to be 21 cm. Estimate the reaction time. So, dropping a ruler here, we found that the h distance to be 21 centimeter. We know that the initial velocity is equal to 0. So we can use the formula s equal to v naught t minus half at square, half gt square. So distance here is 21. Initial velocity is 0. So we got half into 10, or because they haven't mentioned it to take it as 10, let's take 9.8 into t square. When we simplify this, we get t square equal to, t will be equal to root of 9.8, it will be equal to root of 21 into 2 by 9.8. Solving this, we get t is equal to 0.2 seconds. This is our reaction time in this particular case. Example 3.9. Two parallel tracks run north to south. Train A moves north with a speed of 54 km per hour. So we've got train A, which is moving north. So it's moving from south because the train is parallel rail tracks run north to south. Okay, and it's moving with a speed of 54 km per hour. Now what about train B? Train B moves south. Okay, so train B is moving south with a speed of 90 km per hour. You're supposed to find velocity of B with respect to A. That is the A part. Now, if we consider this direction to be positive, this direction would be negative. Because they're moving in, one is moving along positive x-axis and the other is moving along negative x-axis. So what would we get? Velocity of train A would be 54 km per hour. Now let's convert this into meter per second. If you multiply by 5 by 18, we get the velocity to be 15 meter per second. Now what about B? Velocity of B would be negative 90 km because it's moving in the negative x-axis. 5 by 18, we get this to be negative 25 meter per second. Now the first part of the question is to find the velocity of B with respect to A. Now how do you find the velocity of B with respect to A? Velocity of B with respect to A is equal to velocity of B minus velocity of A. Now what is velocity of B? Negative 25. Now what is velocity of A? 15. So when we add this, because it's negative, we add it. Would we get negative 40 meter per second. Now, let's see what the B part of the question is. This was the A part. Now, what is the B part of the question? Velocity of ground with respect to B. Velocity of ground with respect to train. So this will be velocity of ground minus velocity of train B. What is the velocity of ground? Ground is at rest. This will be 0. Minus, what is velocity of B? Is negative 25 meter per second. So this will give us the final value 25 meter per second. Now, what is the third part of the question? Now let's solve the third part of the question. The velocity of a monkey running on the roof of the train A against its motion with a velocity of 18 km per hour with respect to the train A as observed by a man on the ground. So what is given to us? We have the velocity of monkey on the roof of train A against its motion with a velocity of 18 km per hour with respect to the train A. So we got VMA equal to 18 km per hour. But what is it? Is it positive or negative? We know that, like we spoke before, we've got the train A, which is in the positive direction. But over here, the monkey is moving in the opposite direction. So this would be negative. Right? Look at this. It's against its motion. The monkey is running against its motion, the train's motion. So this would be negative 18 km per hour. Now let's convert this into meter per second. So how do you do that? Multiply by 5 by 18. So we get this to be negative 5 meter per second. Now, what is VMA? What is velocity of monkey with respect to train A? Yes, velocity of monkey minus velocity of train A. So what is this? We know this is 5 meter per second. What is velocity of monkey? That is what you have to find out. Now what is velocity of train A? That is 15. That is positive negative 15. Now rearrange it. What do we get? We get velocity of monkey to be equal to 10 meter per second. Now the question is to find out the velocity of the monkey as observed by a man standing on the ground. Now what is the answer of this? Velocity of monkey respect to ground would be equal to velocity of man minus velocity of man standing on the ground. What is velocity of monkey we found out? Found it to be 10 meters per second minus what is velocity of man standing on the ground to be? That would be 0. So we've got the velocity of monkey with respect to the ground to be 10 meter per second. This is our answer.